All right, so you can see both of these, well, all three of these forms have an exponent in them. And so whenever we have this kind of indeterminate form, the way that we're going to approach this is we're going to take the log of both sides, we're going to find the limit then we're going to use that limit and exponentiate to find the limit of the original function. All right, so let's go through that step by step. Let's look at an example. Here I have x raised to the power of 1 over x. And the limit of that as x approaches infinity. All right, so if I just try substitution, I get infinity to the 0 power. I get infinity raised to the 1 over infinity. And that's an indeterminate form, but it's not one we can apply L'Hopital's rule to right away. So I'm going to let f of x equal that function I'm trying to find the limit of, x raised to the 1 over x. And I'm going to take the natural log of both sides. All right, once I do that, this 1 over x now can come in front and become the coefficient. So I have 1 over x times natural log of x. So I have natural log of x over x. So now I'm trying to find the limit as x approaches infinity of the natural log of f of x. That is equal to the limit as x approaches infinity of ln of x over x, and that is infinity over infinity. So we can use L'Hopital's rule now to find this limit. So I'm going to differentiate the numerator. I get 1 over x. Differentiate the denominator. I get 1. I'm still trying to find the limit as x approaches infinity. And when I plug this in now, well, this is just simplified. This is just going to simplify to 1 over x. And of course, as x approaches infinity, that denominator gets extremely large without limit. And so I have the limit is approaching 0. Right? So keep in mind what I've found here. That 0 is the limit as x approaches infinity of the natural log of f of x. That is what I've just found there, right? We had that step up here. So we've actually found the limit as x approaches infinity of the natural log of f of x. So I want the limit as x approaches infinity of just f of x. So watch how I'm going to rewrite this. We started out with this problem. All right, we want the limit as x approaches infinity of f of x. I have the limit as x approaches infinity of ln of f of x. So in order to get that, I'm going to take e, raise it to the ln of f of x. Okay, think back to exponentials. E to the ln of anything is just that function or just that value, whatever that might be. So this is really just the limit as x approaches infinity of f of x. All right, I found this, the limit as x approaches infinity of the natural log of f of x, to be 0. So now this is just e to the 0, which gives me 1. All right, so that means that the limit as x approaches infinity of x to the 1 over x is 1. All right, so that was an example where we started with an infinity to the 0 power up here. We took the we took the logarithm of both sides. In this case, I used ln. We found the limit of that, and then we exponentiated. We essentially exponentiated that limit to find the limit of the original function.